Hi, my name is Yoav Artzi, and I'll be presenting the third case study, CerealBar, together with Alane Suhr. This section of the tutorial is divided into three parts. I'll be presenting the first one and Alane the later two. The first one discusses game design, incentive structure, and the tasks that are available that have been studied with CerealBar, while the later two discuss the crowdsourcing data collection process and the resulting corpus. CerealBar is a situated collaborative game with sequential natural language instruction following. It emphasizes interaction where participants respond to each other's language and behavior across multiple turns. And it emphasizes collaboration, so participants are incentivized to work together and must coordinate using natural language. This is the CerealBar game environment. This is an overhead view of the complete game environment. This environment is procedurally generated randomly for each game. So each game gets a unique instance of the environment. This environment includes various elements, including passable terrains like the grass and the roads, impassable terrains like water bodies and the mountains, landmarks like a windmill, different houses with different colors, roof colors, tents and different vegetation, and different cards that are randomly distributed in the environment, and each card has a number of elements on it. And this can be, it's a different number of elements, so 1, 2, or 3 elements with different colors and different shapes. So for example, this card here includes two orange squares, and this card has 3 purple stars. And in general, the environment is designed to elicit relatively rich natural language and spatial descriptions and references. So for example, when we introduce houses into this environment, we allow the system to procedurally generate them with different colors of the roofs. So when natural language is used in this environment, it can discuss the house with the red roof or the house with the green roof and so forth. In this environment, we have 2 agents, a leader and a follower. The leader is the colorful figure on the right, and the follower is the monochromatic figure, in this case on the left. The 2 agents play a game that is very similar to the card game set, for those who are familiar with, but in a spatial environment. So that means that they collect valid sets of 3 cards, where a valid set has a unique color, shape, and count. So each of those 3 properties is unique in the set. Each set that is completed awards the 2 players together a single point, and the goal is to maximize the game score. So just to kind of to illustrate the types of sets of cards are collected. So the set that is on the left is a valid set. Each of the properties, the color, shape, and count, is unique. So the color green, each color green, pink, and purple appears once. Each count 2, 3, and 1 appears once, and each shape each shape that appears here also appears once: triangle, star, and heart. On the other hand, the set on the right is an invalid set because the count 3 appears twice. The 2 agents collaborate in this environment and by taking turns. So each of the 2 agents moves in their own turn with a limited number of steps per turn. They move around the environment to select cards, and they flip the selection status of a card to being selected or not selected by stepping on it. When a valid set of cards is selected, so these are 3 cards with unique color, shape, and count, are selected, they disappear, and new random ones appear in random places in the environment. So the sets of cards that are in the environment constantly changes. So let's look at a very simple example that illustrates the dynamics of the game. So here at the bottom, we have a snapshot of the overhead view of the game. On the right is the leader, the colorful image, and on the left is the monochromatic image of agent, which is the follower. This interaction starts with the leader turn and they go and pick the yellow plus. Then the follower gets their turn, they turn around and they grab the 3 red bars. And then the leader will get their turn and they'll complete the set with the 2 pink stars. And the cards disappear and new cards appear in the environment and the interaction continues. One important aspect that we want to emphasize in CerealBar is collaboration, and one of the things we want to do is reward successful collaboration. So when games go well, we want to let the players, let them keep playing and play for longer time. So in each set completion, which indicates a successful completion of an objective in the game, the players get a point together, and they also get additional turns. So this gives them the ability to complete even more sets. So now they can play for longer, complete more sets, and get even more points. And during crowdsourcing, as Alane will discuss in the second part of this presentation, this allows us to get more data from effective interactions, and effective workers make more money because we pay them according to the number of points they're getting. So this further reinforces the incentives of the game. You don't only get points for completing sets, you also get the ability to get even more points. So if you would like to think about it, you can think about it as like a rich get richer kind of a scheme. Because a player constructs sets together in the game, they must coordinate their action and their plan. And the only way we allow to do it in the game, the only channel of interaction, is through unidirectional natural language instruction from the leader to the follower. And this begs a very common question of why didn't we create a bidirectional natural language communication channel where the two can interact and ask for example, for the follower to ask for clarifications or to share information. And the reason we avoided this is it's a design choice, because a bidirectional communication channel would have dramatically complicate the learning problem of learning the agent models. So we wanted to, an important design decision in the design of CerealBar is to scope the complexity of the problem so we can use a more principled learning approaches with limited need or even with no crutches. So usually when you think about more bidirectional dialogue systems, addressing the problems that they create effectively requires a relatively sophisticated machinery and a lot of engineering, where the focus of CerealBar is to allow you to study like core machine learning problems and language understanding problems. So the leader's role in CerealBar is to give instructions to the follower, whereas the follower's role is to follow the instructions. And together, both of them, regardless of this role, they move in the environment and they select and unselect cards in order to complete sets. So the leader can write as many instructions as they want per turn, as long as the follower has one to follow. So we really ask them to give instructions, but once they give instructions, they can actually buffer multiple instructions by planning ahead. The follower's role is to follow as many instructions as they want or can per turn, or potentially they can, depending on the instruction, it might actually take them multiple turns. So an instruction can cross turns. Now, an important aspect of how we design CerealBar is that it will give us a very clear and explicit alignment between natural language instructions and the actions it entailed. So if leader gives multiple instructions, it begs the questions of how would we know which actions correspond to which instruction. If we show all the instructions to the follower, they might just execute all of them, and we'll get this really long sequence of instructions with a really long sequence of actions, and this will have a very difficult data learning problem. So one solution, and this has been done in other resources like Room to Room and our own Touchdown resource, is to just learn this alignment. This dramatically increases the complexity of what is already a very complex setup. So instead, we use a first in, first out queue to store instructions. and we only display the next instruction to the follower. So even though the leader can buffer multiple instructions, we only show the next one to the follower. And this also prevents the follower from reasoning about future tasks when executing the current instruction. So if the follower could see what are the future tasks, maybe they would just decide to do some actions that are entailed by those tasks when executing the current instruction, which would give us a poor alignment and a kind of like credit assignment between actions and instructions. So how is this done? The follower only sees the first incomplete instruction in the queue. In order to get the next instruction, once they complete the current instruction, they have to signal that they have completed the instruction by pressing the done button when they're finished the instruction. Now, if there are more instructions in the queue, they will see the next one. If there are no more instructions, even though they have some steps left, their turn will end, and the control will switch to the leader. So this gives us a very accurate alignment. The follower can't mark done early, or they will risk ending their turn and losing steps that they could have used otherwise. On the other hand, they can't mark done late because they actually don't know what's coming next, or even if there is another instruction. At the same time, in our above, the follower sees previously completed instructions, and this allows the follower access to the history of the interaction. For example, it eases the ability to resolve dependencies like pronouns that are doing co-reference to previous instructions. Now, how do we? Now, a very important aspect of CerealBar is the natural language instruction, and we really want to incentivize a useful and effective natural language instruction as part of the game. And to do this, we design the two agents to have somewhat different abilities and knowledge about the world. So they must use language to bridge those differences for the most effective interaction, which will allow them to maximize the score that they can get in the game. So the first type of difference is the observability. The leader sees the whole board, while the follower only sees a first-person view of what is ahead of them. So they're under a very strict partial observability setup. So what this entails is the leader is responsible for planning what cards both players should get. And because they see the complete board, they can actually plan this in the most efficient way. The follower, on the other hand, doesn't see the complete board, so they don't have this ability, which disincentivizes them from wandering around and selecting unmentioned cards. They also don't know what the leader is collecting at the same time, and if they would collect they will collect cards that conflict with what the leader is trying to play, and they will basically sabotage each other. This means that the leader instructions must be grounded in the follower's first-person view and partial observability. And this means that as far as language, these instructions really need to include spatial relations and refer to the environment. The leader can't just say, go and pick the two red diamond card, because it's very likely that the follower doesn't see the card in front of them, so they have to turn around and navigate in the environment using the landmarks that they do see in their first-person view in order to find this card. So this does not only incentivize and forces them to collaborate in order to achieve efficient and optimal interaction, it also gives us much richer language. The second type of gap between the leader and the follower is in their ability to act in the environment. The follower has 10 steps per turn, while the leader only has 5. And this encourages the leader to delegate longer, more complex paths to the follower, for instance, using more interesting language. It also means that the leader can't just ignore the follower and expect to do well at the game. In fact, because the distances in the game, even with the expected distance of the game, of objects and the size of the board, a leader that will decide not to use the follower and just go and act on their own will achieve extremely suboptimal performance in the game and will get a very low score and will have a very short game because they will complete very few sets, if any. So let's illustrate how these two different perspectives look like and how it plays into the partial observability and instruction following. So at the top, so this is going back to the same very simple example that we used to illustrate the dynamics of the game. At the top is a crop of the overhead view of the leader, and we can see here the leader on the right and the follower on the left. At the bottom, it's the partial observability first-person view of the follower. In this case, the interaction starts by the leader giving the instruction, grab the free red stripes behind you. So this is exactly the same kind of, they're going to collect the same set that we saw in the simple illustration of the dynamics earlier on. Now, from its first person view, before I start the videos, we can see that the follower doesn't really see this card. So it really has to follow the instruction in order to find the card and complete the task that it is assigned by the leader. So when this interaction continues, the instruction starts, the leader gives the instruction, and then they go and act in their own turn. They collect the yellow plus. The follower gets their turn, they follow the instruction, turn around, do what they are told, and then the leader can complete the set, and they are both getting a point and extra turn. Now, another important part of CerealBar is that it is designed to support multi-turn interaction. And this is really fundamental, that we have this interaction that happens across many turns. And this allows adaptation between the player's behaviors, correction of mistakes, and formation of common ground. So for example, if a leader gives an instruction and the follower doesn't do it well, it can correct by giving another instruction, or it can decide to delegate other tasks to the follower, adapt their expectations from the follower, and decide that certain things that are more difficult to delegate to this follower, they are going to do on their own. So the interaction can still continue, they can still do very well by adapting to each other and understanding what to delegate to the other side. So how does this look actually in the game? So this is the leader view. This is what the leader sees from their perspective, including the complete game interface. They see an overhead view of the map. This is what we see here of the entire environment. And there is a small marker here that marks their role, and we give them some statistics about times, how much time is left for their move. So everything is timed because we want to keep things happen dynamically. How many moves they have left in their turn, and how many turns left in the game. The time here is a very large number, so it's fake just because we capture that from our debug scenario. Usually it's between 30 and 40 seconds per turn for a leader, and significantly less for a follower that doesn't really need to write instructions. This is the command view. So you can see here that the follower completed, marked as done, multiple instructions. They're currently doing this instruction, then get the 2 blue stars. And there is one instruction in the buffer that the leader gave but wasn't sent yet because the previous wasn't marked as correct. We also, so this is the buffer, and here at the bottom is where they type the instruction and press send. We also illustrate to the leader what the follower perspectives look like, so they can reason about partial observability better and give more accurate instructions. And this is this follower's view here at the bottom. When a card is selected, like we see here, if it's part of a set that is potentially could still be valid if more cards are selected, we are giving it like this a bright frame, where if this card invalidates the currently selected card, so the set can't be valid, it will be marked with red. So there is some indication for correction. There's still some level of occlusion from the leader view, for example, from mountains. So we also give them the ability to switch to a top-down view by pressing the camera view here. So this gives them like this overhead view of the environment. It doesn't really capture the 3D properties as well, but it allows them to overcome occlusions from mountains and other elements. This is how the follower view looks like. The follower view is the first person view, so you can already see how much more limited and partial observability it is. Now the follower can't just overcome this partial observability by moving around because steps are expensive and they have limited number of steps per turn. Just like we mark here what is the role, the follower, and we give the same statistics that we give to the leader. And here, all the statistics are fake. These numbers are simply because we took this screenshot in our debug view. The command, this is the command view. In this case, you can see that the follower, that there is only one instruction. There was no previously completed instructions, and the current instruction is given here. When you complete the instruction, they can press the finish command button, and this will allow them to see the next instruction, or if there is no next instruction, their turn ends even if they have steps left. There is one more important decision that we made here that distinguishes the follower view from the leader view. In the leader view, we are showing the outline of the hex grid and this helps the follower to navigate. While we are not showing to the leader, so if you go back to the leader's view, you don't see this hex because we don't want instructions that are just telling the follower move forward 3 steps or something like this. So it's much harder to count without the grid, and we are not seeing this kind of instructions. We want more reliance on the spatial environment using more richer language. Okay, so I'm just going to conclude with this section with some technicality. So CerealBar is implemented in the Unity cross-platform game engine, and this is really important because it gives us a relatively powerful game engine in order to develop this kind of relatively complex framework. It also allows us to compile the game to WebGL, which is critical for in-browser support. So the minute we compile to WebGL, we can run it in the browser, and this, as you can already kind of imagine, is really important for crowdsourcing, especially using Amazon Mechanical Turk. You don't really want people to have to download binaries and have to run them. In the backend, we have a multiplayer server implemented in Python with support for various agent controllers. One of them is the game connecting with a human operator, a human player, and this is what we do during crowdsourcing, for example, and in more recent work when one of the agents is a human and the other is a model, or it can be a neural network model like a PyTorch, or basically anything that you can run on the backend side. It doesn't even have to be in Python because the API basically allows you to connect over sockets to the server and replace the kind of agents that you're using with. We also have the ability we also replicated the complete game in Python in a very kind of lightweight and fast implementation. And this allows for non-supervised learning scenarios like reinforcement learning that requires actually rolling out in the environment, which would have been much more computationally heavy and difficult with our Unity client. With the Python client, we can do it as long as we don't need access to the visuals. And this is one more important thing that kind of is entailed from the design of CerealBar using this discrete environment, that we can actually implement this relatively simple and lightweight Python version. So CerealBar has been studied in the past for 2 main tasks. The first one is in the original paper we introduced it by Suhr 2019, where the task was instruction execution. We want to learn where we learned a function that takes an instruction, the history of the interaction, and the first person observation from the leader perspective, from the follower perspective, sorry, to generate follower actions. The second task we studied in a more recent paper, it's a title paper, Kojima et al. 2021, that is presented here in EMNLP, where the task is natural language instruction generation. So we want to learn a function that takes the overhead view from the leader perspective and the history of the interaction to generate an instruction to give to the follower to execute. And now I'm going to pass the baton to Alane to present how we actually collect data with this platform and what kind of data we are getting.
Okay, so now we're going to talk about crowdsourcing. So we collected all this data on Mechanical Turk, and I'm going to go in detail now about how we actually managed this. So we defined some tutorials and qualifications to train workers. I'm going to talk about how we managed the games, how we paid workers, how we split workers into different pools based on their expertise, how we communicated with them, and then finally how we got our final data set out of all of this. To qualify for the tasks, we required workers to complete a short tutorial, pass a short quiz, and then also live in a country where English is widely spoken. So all of our data is in English. We ended up with a total of 264 qualified workers from this process. So there were just two short tutorials, one for the leader role and one for the follower role. In the leader role, we asked players to write an instruction and also pick up 3 valid sets. So this teaches them how to use the instruction writing interface and also how to, and also gave them practice on what makes a valid set. In the follower tutorial, we gave them, we had them follow 3 pre-written instructions. And basically this just teaches the users how to navigate around the environment, and also how to use the command interface. In the quiz, we had a few questions about how to make sets, so like what makes a valid set, and then about the different players' roles, and we gave workers an extra bonus if they passed both the qual and did the tutorials. In terms of managing the actual games, as we were collecting data, our server matches players as they join and assigns the roles randomly, so they don't know if they're going to be a leader or follower when they start a game. We make sure that the players only have access to one game at a time, so they're not playing multiple simultaneously. We have a waiting room where people wait until another person joins that can be their partner, but this room also will time out if no one else is online because we don't want them to have to wait forever for a partner. But that doesn't happen super often because we let players know ahead of time when we would put out batches so that they could plan to be online. So we really didn't have situations where people didn't have a partner until the very end of a batch. So in terms of pay, we had a small base pay per game regardless of their score, and then we gave them an additional bonus for every point they earned. We actually increased the bonus as they score more points, so the 10th point will have a higher bonus than the 2nd point, and this is incentivizing them to keep playing for longer because they want to really get high scores. And we give both players the same bonus. We didn't want them to prefer one role over another, and the median cost per game was $5.80. We split our worker pool into 2 different pools of workers on 2 different servers based on their expertise. So workers will start out in our novice pool where the pay is a little lower and they're paired with other novice workers. The expert pool has more hits available and a higher pay per point. In order to get into the expert pool, a novice has to play at least 2 games as a novice, one as a leader, one as a follower, with earning at least 1 point in both of those games, and then they can play games in the expert pool. Besides sort of being able to label games by whether players are experts or not, this is good for training people to play the game because then they have hands-on experience with it, but it also has this added benefit of not making expert workers train the new people, which is something that they gave us feedback on early on when we didn't have this separate pool system. So we found this was really useful for keeping people letting people have the best experience while also training some of our new workers. So when we communicated with workers, we used a variety of methods. So we would use email and we would hang out on the Mechanical Turk forums. We found this was really important for this kind of task where people are actually being online and interacting with each other. So we tried to be as really responsive to questions, comments, suggestions, etc. And more recently, in other work we have with CerealBar, we created Discord servers to actually talk to workers in real time over like a chat interface. And that has been really useful because they can easily just ping us when there's maybe a problem with the server or something like that, or when they have questions or want to make a note of how well, how well games are going for us. So this was really important to our process. So finally, we after we get all our games, we filtered out some of the games that we thought might be violating some of the game guidelines we had. So for example, we wanted to filter out games where the follower didn't know how to mark instructions as done. So for example, we removed games where the followers' action sequences were way too long. This ended up removing about 20% of the games. So we ended up with 1,200 in the end in total. We didn't filter out games with no points because actually a lot of those had pretty good instructions. It was just often a matter of the card placement was not, what made it very difficult, and or someone accidentally left the game early. Okay, so we ended up with 1,200 games and almost 24,000 instructions, with a median score of 9 points. The maximum score, I believe, was around 20 points, which is pretty good. Very impressive, actually. In each interaction, we had an average of 24 instructions, a median length of 13 tokens, and a median number of 8 follower actions per instruction. And our vocabulary size is pretty big at about 3,600 tokens. Okay. So I'm going to show a few examples from CerealBar, from the data we collected. So here I'm showing in the middle is the leader's view, and in the bottom left is the follower's view. And sort of in the middle of the leader's view, you can see the leader, and then the right near the iceberg is the follower. So the leader writes, turn left twice and head straight toward the doghouse and look for 2 green circles to pick up. And this is actually a snippet from a game that 2 workers played. So the follower will turn left, go this way, and then kind of turn towards and get the 2 green circles. So now the leader is wrapping up this last set and writes, turn left and head toward the yellow hearts, but don't pick them up yet. I'll get the next card first. So in this instruction, the leader is saying basically to prepare for the next set, but don't actually select anything because then it'll take forever for us to get this current set. Because we'll have to undo things and whatever. So the follower turns left and the leader selects the set. And now the leader says, okay, pick up yellow hearts and run past me toward the bush sticking out. On the opposite side is 3 green stars. So this requires the follower to pick up multiple cards, and including one that they really can't see from this perspective, and also understand what various references are referring to. So me refers to the leader, and the bush sticking out refers to a bush that's pretty far away from the follower. So the follower does this. They select the 2 yellow hearts, then they move towards this bush, and then they go. And then what happens is that the leader will issue another instruction, preparing for the next set. So this is something that leaders often will do if they can tell that the follower is really going to do what they ask. They'll just go ahead and plan in advance. So the leader here says, after you get that, pick up the 3 pink crosses to the left and the 2 yellow stars to the right. The follower can't actually see this instruction because they're currently working on the previous one, but they will be able to see it once they finish it. So for example, the follower turns left a little bit, goes around this pink cross card, and selects the last card in the set, and they earn a point. So to summarize our data collection procedure, we first designed the game and thought about basically what we wanted out of it. Then we designed the qualifications, and then we did some pilot and refinement cycle, both with workers and also people at Cornell. And then finally, we had our main data collection cycle and then filtered the data and split it into training and test sets. So some takeaways and lessons we learned from this experience was, I guess to summarize a lot of them, was to think sort of adversarially about how the design might influence the kind of language we get and how it might influence, the language and behavior we get. So it was really important to directly incentivize success in our task. So rather than paying people per game they played, we paid per point. So they were incentivized to earn high scores and to complete the tasks. We also made sure we designed the game so that the collaboration is really, really critical for success. So for example, we don't allow the follower to have access to see when a set is invalid because we don't want the follower to reason about the game rules. We just want the follower to follow instructions. We also carefully considered how the design might affect the language that's being used. So for example, we don't show the hex grid to the leader because we don't want them to say something like, it's 8 hexes forward and 2 to the right. We really want them to make references to the objects in the environment. And then finally, another big takeaway is that communication with the workers is really important. We found it really useful to get feedback from them and be able to answer their questions and give some guidance as they were playing the games. This was really critical, especially for this like hands-on multiplayer sort of game. And finally, I wanted to just acknowledge and thank the entire team who worked on this project. Claudia in particular, Claudia Yan was the lead developer for the Unity platform lead developer for CerealBar on Unity, and put a lot of effort into the game. And then the other folks in this list also did a lot for our project as well. And so very grateful to them and just wanted to acknowledge them. So thank you for listening. And if you have any questions about this data, this process, or if you have something similar that you're working on that you have questions about, then I would be happy to chat about it. Thanks.